Hello everyone, and now we're on to the second lesson of covalent bonding. So we did atoms in the periodic table, now we're on to structures and bonding. We looked at ionic structures, and soon, looking at all these rules, these are what we're trying to learn as we go along, right from very first thing of what the atoms tell us on the periodic table, how many protons there are, and the mass. And remember, if you can learn these every time, every lesson, if you go through these rules, eventually they'll just be there in the back of your head whenever you need them. It makes the whole of chemistry much, much easier to understand. Right, today's title in your books. Last lesson it was sharing is caring, and we introduced covalent bonding. And today it's the originally titled Sharing is Caring again. And look at those little doggies sharing. Ah. Anyway, bit of work from you. Title you've got Sharing is Caring again, and then could you write the questions and fill in the gaps? And the last question, question 4, why is oxygen O2? See if you can put an idea down about that. So pause now, have a go at those, and then when you're ready, unpause. Welcome back. That's probably taken you 3 or 4 minutes to do those questions, so let's go through them. Choose the right colour pen. Bonding between metals that become positive and non-metals that become negative. That is always ionic. And bonding between two non-metals, there's the one we were dealing with last lesson, covalent, where they do the sharing, hence why sharing is caring. The atomic mass is something and something added together. Electrons don't weigh anything, so it must be the protons and neutrons. And why is oxygen O2? Because oxygen has the number 16 and 8 on the periodic table, and when you draw out oxygen, you've got 2 electrons in the first shell, and you've got only 6 left to go in the next shell. So, if it's only got 6 electrons on the outside, oxygens can pair up together and do covalent bonding. So the answer to the question is they go round in molecules as pairs. Okay. Don't worry if question 4 was confusing or you left it, because that's what we're really moving on to today. So where did we get to? We were on this and we talked about what if both the atoms were non-metals, so a non-metal and a non-metal, both want to take electrons, take and take, to fill up their outer shells. And we decided that ionic bonding, where electrons are transferred from one to the other, that's the most important word on the page there, was for metals and non-metals. But when we had a non-metal and a non-metal, they do lovely sharing. So they share their electrons and they go round as molecules. So hydrogen here goes round as H2. And that's where we got to last lesson. Now obviously the Kahoots are only done in the live lessons. So here was a hydrogen ending up with 2 on its outside shell, 1 of its own and 1 sharing with oxygen, so it's got 2. Oxygen ended up with 8, a full shell, and the hydrogen over here 2, a full shell. And this is called its structural formula. And in the last topic we dealt with formulas, so the formula itself is H2O, but the structural formula shows you those 2 covalent bonds drawn as straight lines. So let's move on. What's next? Now, you may have got to this in the last lesson. Oxygen here with 6 on the outside. Remember, oxygen has quite a deep voice and says, "Oh, I'm really unhappy." Oh, I don't know why it's unhappy. I'm really unhappy because I haven't got a full shell. And I'm really unhappy because I haven't got a full shell. And we dealt with the idea that maybe the atoms like this, non-metal atoms, could go together and do some sharing of electrons. So this one, why is it unhappy? Well, it's got 1, 2, 3, 4, 5, 6. So actually, let's write that down. It needs 2. And this one has 6, so it needs 2. So what we've been doing before is overlapping the shells and sharing electrons. So in this case, let's do the same again. O for oxygen. There's the nucleus. There's the first shell with 1 in it, 2 in it. And there is the outer shell where it's going to have its 6. 1, 2, 3, 4, 5, 6. Now I'm deliberately going to change colour to draw my other oxygen. This fella, he's going to be a blue one. He's already feeling blue. So I'm going to go O for oxygen in the middle, in the nucleus, and then I'll draw my first shell in with its 2 electrons, and then I'll draw my next shell in. Oh, my diagram's a bit dodgy, but what, you know, you can't have everything, can you? 1, 2, 3, 4, 5 and 6. Now this is different than anything we've done before. The type of bonding is still called covalent. Have a think, what's different about this one? Just that thinking moment. In all the ones we've done so far, they've been sharing a pair of electrons. But now we are sharing 2 pairs. This oxygen wanted to share 2 and share 2 back. So now look at it. 1, 2, 3, 4, 5, 6, 7, 8. Each of them can count 8 in the outside shell. They are now full. In my terms, they are now happy. They have a full outer shell. Hurrah! So, how do we draw this differently? When we drew hydrogen, we drew a hydrogen and a line between the hydrogens to show a covalent bond. So all we do now is, there's an oxygen, there's an oxygen. What do you think we draw instead of a line? You're right. We draw 2 lines. And we actually say that this, instead of being a single bond, oxygen bonds with a double bond. So think back to 5 minutes ago when we did question 4. Now we have O2, molecules of oxygen, the gas we breathe in from the air, the gas that's needed for burning, oxygen gas, is always O2 because they always go round like this in pairs. Right, once you've had a chance to write that down and do that as your worked example in your books, the next thing was to try these. Draw covalent bonding diagrams for fluorine, hydrogen fluoride, ammonia gas and methane. And some of you might have tried this at the end of last lesson. So you pause now, you look at your periodic table, you draw out, for example here with a hydrogen fluoride, you draw out a hydrogen, put the electrons on, you draw out a fluorine, and then you put them together. And this time you can see HF is the formula, so it's only one of each. These ones down the bottom, C and D, that looks a bit more complicated. CH4, NH3. So we're going to do one of those as a worked example. And if you don't need that, you can fast forward through that bit. So, my nitrogen. Hello, I am very, very unhappy. I'm even unhappier than hydrogen or oxygen, so I'm going to have a massive downy face. And the reason I am so unhappy is because I need 3 to fill up my shell.
And I'm still unhappy because oh, no. I'm unhappy because I still need 1.
So when we put these together, I'm going to draw my nitrogen first. Just copying it down from the top there. It's got 1, 2, 3, 4, 5 on its outside shell because its number from the periodic table is 7. So 2 in the middle, first row, and 5 on the outside. And here's hydrogen. Right. Along comes a hydrogen here, and that hydrogen can share 1. That hydrogen's fine. And ammonia started with 5 electrons in the outside shell. It's now got 6. So along comes another, hello, I'm hydrogen, I'll share with you. And the hydrogen's now happy. And the nitrogen is saying, oh, I am much happier than before because now I've gone up to 7, but it's still not good enough. Okay. A third hydrogen comes along, lends it another one, and that hydrogen's happy. And now all of a sudden, nitrogen is up to 8. It has a full shell. So with NH3, the nitrogen has a full shell. Hydrogen, hydrogen, and hydrogen. The formula of ammonia gas is NH3. Now ammonia is an alkaline substance. It's a gas. It's very soluble, so it dissolves in liquid easily. So you can get liquid ammonia, and actually ammonia is a very strong smelling substance. Where would you have smelt it before? You'd have smelt it if you own creatures like rats or mice or ferrets, and they produce ammonia in their urine, in their wee. So they need cleaning out quite a lot because of the smell of that ammonia. So quite often mouse and rat wee smells really bad. You clean them out every day. Where else might you clean it? A lot of cleaners, a lot of substances. It's a cleaning substance used in oven cleaners, etc. There'll be a lot of ammonia in there, and you have to be careful when you're using them, and it says to be careful not to breathe them in too much because it's dangerous. But ammonia gas, NH3, which is very soluble, so it can be a liquid, they all have full shells. It's not NH4, it's not NH2, it's not NH17. Okay, hopefully you got that answer right yourself by trying the questions. But if not, that's my idea of a worked example, so that now you can go back and try those other ones on the previous sheet. And this is what you should have got. For fluorine, F2, they're sharing 1 pair of electrons here in the middle. Give yourself a tick. For hydrogen and fluorine, they're sharing 1 pair. Give yourself a tick. The ammonia one I just did with you. And very similar to that is the methane. Carbon needs 4, so it shares with 4 hydrogens. Now you need to be able to represent the covalent bonding in any of these simple substances. Either they give you the formula and you draw out the structure, or they just give you carbon and hydrogen and you work out, by drawing out the structure, you then work out the formula. And then you'd be able to answer any of the questions on this. Now, the next question is, for covalent substances, what is the structure? So when we did ionic had positives and negatives, and it had them in all directions, and it built up into great big things, and we did giant crystal lattice. I'm just doing it in short now because this is just going over, and they were solids, and that's the structure. So the bonding is ionic, the structure was a giant crystal lattice. It was a solid, high melting point, high boiling point, and that's all the structure bit of this topic. The structure, the bonding and structure. So the bonding was ionic, the structure was this. So now we've got covalent. Covalent bonding. Sharing bonding. Non-metal and non-metal. So what will the structure be like? Now you might well have some ideas about this, which is great. So I'll just say that you're correct. Here are some of those F2s. Here are some of those fluorines with their bond in the middle here. Now, some people overcomplicate this, but I actually think it's really easy. Fluorine is a gas. So, F2, fluorine is a gas. Oxygen, we've done that, it's a gas. Water, put that down here, that's a liquid. We've done NH3, gas, ammonia. We've done CH4, methane, gas. We've done hydrogen fluoride, gas. So the structure is they are gases or liquids? Why are they gases or liquids? So let's just look at this diagram. Is there weak bonds? No, 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 no. This, and now I'm going to put it in purple. Two really important points for when you draw this diagram. The first most important point is that is a strong, just like ionic, strong bonds, strong covalent bond. So you can't say that the bonds are weak. In fact, watch this. Weak? No. No, no, no. And I can't say that enough times. From looking at exam papers and past papers and questions people have done, they say it's a gas because the bonds are weak. It's not true. It has strong covalent bonds inside each molecule. That's the important bit. Strong bonds inside the molecule. However, what does this fluorine and this fluorine, what do they think of each other? Well, all these fluorine molecules don't really care about each other. They've got no attraction to each other. They've got no repulsion. They're not positive or negative or anything. There's no reason to join together. So, number one, there are strong covalent bonds inside the molecule. Number two, there are weak forces between molecules. What that means, number three, whenever you're trying to answer about this, they are free to move. They are free to move away from each other, free to move apart, free to float around, and that's why most of them are gases. Right, that's the page you need to spend most time on. That linking that fact that they do the sharing bonding and they have the strong bonding, that number 1, 2 and 3, make sure that's really clear in your notes and you fully understand it. If you don't get that, that's what you'll be messaging your teacher about. So, just to recap. Water is a liquid. Ammonia is a gas. Carbon dioxide, gas. Methane, gas. All of these substances have a molecule structure. And the molecules are free to move. So, if you need to, go back to that slide about fluorine and just make sure you could explain, because the same answer for everything. Why, for example, why is methane a gas? Methane a gas is because number one, we just did it, there's strong covalent bonds inside the molecule. But number two, that methane molecule is not attracted to other methanes. So number three, they are free to move. Right, thank you for listening. I'll stop rabbiting on and I'll stop here and I'll see you next lesson.